And welcome back, and it's the Corbett Higher plus 5 a day for the 20th of Feb, and let's go with the first question. Okay, so what do we have? So we have a make C the subject question. In other words, I want to rearrange this equation so it says C is equal to something. Now, this is a slightly tricky one because I've got a 6 plus here, so it's easy to get this one wrong, but actually just follow the steps that you know and learned. So I'm going to take away 6 on both sides, which means that W minus 6 is equal to A over C plus 2. Again, something that's not obvious to do here because the temptation is to multiply by C plus 2, which makes it all much harder. Actually, you can flip it upside down. You can say 1 over W minus 6 is equal to C plus 2 over A. Multiply both sides. Let's go over to here so I've got some more space. Multiply both sides by A, which is going to give you A over W minus 6 is equal to C plus 2. And therefore I'm going to end up, remember I want to make C the subject, so it must be C equals, I've got C equals A over W minus 6 minus 2. And that is my final answer. Now, I say that, you could combine these two things. So what you could do, depending on how you got there, you might have got the answer. I'm going to zoom in for this bit. You could have combined to one fraction. So you could have had A minus 2W plus 12 all over W minus 6. In other words, I make that a common denominator. That is also a completely acceptable answer, but you can see the way that I get there, slightly quicker, I would argue, and arguably slightly neater in terms of answer, but both are fine, both will get you the marks, unless the question tells you to answer in a certain format, of course. Anyway, next question. Okay, so we have a speed, distance, time graph. In other words, now this might say speed and it might say velocity, depending on what you're measuring, what the graph is. But the point is, these graphs are helpful because the change in speed with respect to time, how your speed changes as time changes, is your acceleration. And the amount of speed that you do over time, in other words, if you sum all your speeds up, you get your distance. And that's a long way of saying area under curve equals distance. Right, so I need to calculate the acceleration for this first question. The acceleration is based on working out the gradient at a particular point. Now the point is 6. Now I will say this is hard enough to do an exam with a ruler and with a big graph. It's even harder on an iPad, and obviously you watching at home, even more difficult because you can't draw on your screen. But nevertheless, let's give this a go. So I'm going to try and approximate my line here, which is going to look something like this. Actually, it's probably not steep enough, probably something like this. And then again, I would get a ruler out. I'll do this much more accurately than I'm doing it now. And that will give me these points here. Now I didn't intentionally go to 0, 3, but I just happen to have made that work. Then I need the points A and I need the point B. Now, using the scale of the graph, I'm going to be as accurate as I can here. The fact I've drawn the longest line helps me a little bit to net out some inaccuracies. But either way, let's give this a go. So A is 0 across and 3 up. And B, well, I go 10 across, so I've made my X values easy here. I'm going to zoom in so you can see 9, each square is 0.2, so it's about 9.3. Again, I'm being spuriously accurate here, but I'm just trying to do the best job I can to try and get in that range the exam will allow me. Which means my gradient, which is my acceleration, is equal to 9.3 minus 3 divided by 10 minus 0, which is 0.63. Now, I would suggest to you that anything between, I mean, probably even 0.55, but definitely anything that rounds to a 0.6 is probably fine, if not slightly more than that. Units wise, that's going to be meters per second squared, and I've used the units from here and the units from here, or the units from here technically, I guess. First question done. Next question. Calculate an estimate for the deceleration. Okay, now this is always an interesting one because it's telling you it's negative. So I would just be very clear on my answer, but I'll get to that in a second. So 9 is here. And again, I'm going to do my best of drawing a straight line and extend it as much as I can, try and be as accurate as I can. So my line is going to look something like this. I will say that's not a brilliant line, but it will do. And that's going to be C and D. So for this one, my point C, well, that's going to be, let's map this down, it's going to be 5.2, and then it goes up to 10, so the y value is quite easy here, and my d value, well, the 10 is my x value, and it goes up to, that line's not brilliant, so I'm going to call that 4.6. Now I'm also going down, so I'm expecting a negative number, but let's work out the gradient first. So my gradient is going to be 4.6 minus 10 over 10 minus 5.2. And that's going to be equal to 4.6 minus 10 over 10 minus 5.2. which is minus 1.125. So I'm going to call that minus 1.3 meters per second squared. Now, I mentioned at the start, it tells you in the question it's deceleration. So I would just be really clear here as to what your negative is. So I would say that it's a deceleration of, 1.3 meters per second squared. So I've answered the question and I've also taken care of the issue with a negative. Question done. Next question. Okay, looks like I've got a bit of a functions question. So it's giving me two functions and it says solve. So this is good. So it wants me to do two things. It wants me to build a composite function and then it wants me to rearrange and solve. So let's do the composite function to the left. So g of f of x means I do g to f of x. And f of x takes my thing and does 8 minus 2 times that thing. So in other words, that's going to be 8 minus 2 times the thing in the bracket, which is 5x plus 1. Let's write this down. So this is g of f of x. And let's tidy this up a bit. So it's going to be 8 minus 2 times 5 is 10x. And minus 2 times 1 is minus 2. And all that combines to give me 6 minus 10x. Excellent. Now for part B, or the main part of the question, I have that 6 minus 10x is equal to 0, which means that 10x is equal to 6, which means that x equals 6 over 10, which is the same as 3 over 5, or 0.6. Question done. Next question. A scientist wants to estimate the number of frogs living near a lake. On Friday, she catches 250 frogs and tags them. She then releases them to the frogs. On Saturday, the scientist catches 80 frogs and 35 are tagged. Okay. So the key thing is, on Saturday, she catches 80 frogs and 35 are tagged. I know there are 250 tagged frogs. So in other words, the scale factor to get from here to here is I'm going to multiply by 250 over 35, which means to get from here to here, I'm going to do exactly the same thing. So it's going to be 80 times 250 over 35, which is going to give me 571.4. And I would write that down just to make it clear you've done it right. In fact, actually, let's write what I've done. So times 250 over 35. You can't get half a frog, so therefore I'm going to say 571 frogs implicitly to the nearest frog. And that's question done. Now, just on this last one, you'd probably be allowed 571 or 572 because it's a bit debatable whether you round up or down. It doesn't matter as long as you're showing good working. And that's it. Questions done. Nice little mix of questions as ever today. Do make sure you leave any comments below. Do like and subscribe. Again, I'm going to ask you really nicely if you could subscribe, please. I do want this channel to grow a bit more and it really helps me, the algorithm and all the other things I'm supposed to say. Thanks a lot. Bye.